All right, today we're pulling back the curtain on one of the most critical but maybe least known technologies that makes our digital world go round: MPLS. It's really the unsung hero, the invisible express lane that keeps the internet from getting totally gridlocked.
I mean, really think about it for a second. Right now, millions, maybe billions of us are streaming movies, hopping on video calls, playing games online, all at the same time. How on earth does all that data get where it needs to go without creating a massive planetary traffic jam? Well, the answer lies in this really brilliant solution to a surprisingly old problem.
So, to really get why this was such a game changer, we have to rewind a bit to a time when the internet was a very, very different beast. It was like a tale of two different worlds, each running on its own set of tracks. So in the old days, you basically had two totally separate kinds of networks. On one hand, you had your internet service providers, the ISPs, who gave you access to the public web, websites and email. And on the other hand, you had the giant telephone companies, the telcos, and they provided all these private, secure services, like the VPNs that businesses use. They were like these two parallel universes, and each one had its own super expensive infrastructure. It was just complicated, redundant, and frankly, wildly inefficient. So to fix all this, the whole industry had to evolve. Providers realized, hey, what if we could merge these two worlds into one single unified network? One system running on IP that could do it all. But to make that happen, they needed a kind of secret sauce, a single, powerful technology that could handle all those different jobs on one highway. And that technology was multi-protocol label switching, or as we know it, MPLS. Okay, but just unifying the network wasn't quite enough. There was still this major bottleneck, a fundamental problem with how data moved around. It was just slow and clunky. Imagine you're on a road trip across the country, but in every single town you pass through, you have to pull over, stop, and ask for directions to the next town. That's kind of what the internet was like. See, with traditional internet routing, every single packet of data that showed up at a router had to be stopped and inspected. The router would have to read its entire complicated destination IP address and then do this massive, time-consuming lookup in its huge routing table, its map, just to figure out where to send it next. And this wasn't just a one-time thing. This exact process had to happen over and over and over again at every single router on the journey. Receive the packet, read the address, look it up, send it on, receive, read, look up, send. It wasn't just slow. It created these huge traffic jams right in the heart of the internet's backbone.
So how do you fix a massive traffic jam like that? You build an express lane. And that is the absolute genius of MPLS. Instead of asking for directions at every single stop, what if you just got a simple sticker on your car's windshield at the start of your trip that told every single toll booth operator exactly where you were going?
And here's how that express lane actually works. When your data packet enters the network, it gets a simple little label slapped onto it. From that point on, the routers in the middle of the network, they don't do that big, complicated IP address lookup anymore. No way. They just glance at the simple label and bam, forward the packet instantly. It's really that fast. Now, the routers on this express lane are kind of like automated toll booths. They're called label switch routers, or LSRs, and their job isn't to think, it's just to act. They read the label, maybe swap it for a new one for the next leg of the journey, and then forward the packet at lightning speed. No deep thought or heavy analysis required. And that whole pre-planned route, that specific sequence of automated toll booths your data will zip through, that's called a label switched path, or LSP. It's like the network pre-calculates the entire best GPS route for your data before it even leaves your computer, guaranteeing the fastest and most efficient trip possible. Okay, so this system is incredibly fast. It's super efficient. But the real, honest-to-goodness power of MPLS isn't just about the speed. It's about what that speed and that control actually lets you do. Creating this express lane system unlocked a whole new world of possibilities for what the internet could be. Because MPLS lets providers control the exact path your data takes, they can suddenly offer all these amazing new services. They can build secure, private networks for businesses right on top of the regular public internet. They can do something called traffic engineering, where they basically act like air traffic control, routing data around congested spots in real time. And maybe most importantly for us, they can guarantee quality of service, or QoS. That's the magic that makes sure your video call is crystal clear and your movie streams without buffering, by giving that important traffic priority on the express lane. The impact was just profound. All of a sudden, this new unified IP network could do everything the old clunky separate telco networks could do
and a whole lot more. It really was the key that unlocked the modern internet that we all use today.
So, the next time you're on a perfect video call or streaming a 4K movie without a single glitch, you'll know the secret. It's this simple but totally brilliant idea called label switching. It built the invisible express lane that our digital lives now completely depend on every single day. And that leaves us with a really big question for the future. As our world gets even more connected and our demand for data just explodes, what will the next internet express lane be built from?